Okay, welcome to lesson number 6, roots of quadratic equations and the quadratic formula. Okay, so this is something that you are going to love. Seriously. Now, just a quick review. You've been looking at quadratic equations, and those are in the form of ax squared plus bx plus c, or of x squared plus bx plus c. Now, this first one is in that second form I just mentioned, x squared plus bx plus c, and it's going to take this form x squared plus 7x minus 18, and we want to find the roots using inspection. And so basically we just want to find the roots by looking at this equation, and now we need to find two integers who are going to have a product of negative 18 and a sum of positive 7. And so if we use positive 9 and negative 2, those are going to multiply, give us negative 18, and they're going to add to give us 7. Okay, so those are the integers we want to use, and we are going to just input those, positive 9 and negative 2. But if we're looking for our roots are going to be negative 9 and positive 2. All right, and so that's how you solve by inspection. Now, let's look at how we solve by decomposition. Now, remember, this is just review. You should already be a pro at doing this. Okay, and so if we want to solve this equation by decomposition, it's 6x squared minus x minus 12 is equal to 0. And so we want to have two integers whose product are negative 72, 6 times negative 12, and whose sum is negative 1. Okay, and so let's say negative 9 and 8. Those are going to add to give us negative 1 and multiply to give us negative 72. And so if we're starting with our original equation of 6x squared minus x minus 12 equal to 0, remember that when we decompose, we're actually decomposing this middle term of negative x. So this will be equal to 6x squared minus 9x plus 8x minus 12, and that will be equal to 0. And then we want to group these four terms, and so these two and these two. And for here, we'll be able to factor out, looks like a 3x. Okay, so when I factor out that 3x, I'll be left with a 2x, and looks like a 3. And over here, I'm going to factor out a 4 from 8 and 12, and I'll be left with the same thing of 2x minus 3. And so then I have my factors of 2x minus 3 and 3x plus 4. And if I'm looking for my roots, then my roots are going to be x is equal to positive 3 over 2 or negative 4 over 3. Okay, so those are my roots using decomposition, and above I used inspection. Now, let's think about this equation. Is it possible to solve this quadratic equation 2x squared minus 8x plus 5 by either of the above methods? And so, first of all, we can't use inspection because we can only use inspection when our a value here is equal to 1, but this time it's equal to 2. So inspection, and I'm not even going to spell that properly. Inspection is a no-no. Now, how about decomposition? Well, let's first think of it. To use decomposition, we need to have two integers who are going to have a product of positive 10 and who are going to have a sum of negative 8 or a difference of negative 8. And so if we think about two integers, there's actually no two integers that are going to give us these answers. So we can't use decomposition either because we don't have two integers that are going to factor to give us that. So we have to use a different method. And this is when we use, well, we could use one method of perfect squaring, completing the square, which you saw earlier. Now, we can use that method, but later we're going to try another thing called the quadratic formula. Okay, and before we do that, though, let's complete the square. Okay, so we're completing the square, and later we'll use the quadratic formula. Now, in order to complete the square, we need to remember, factor out this 2. So we're factoring out this coefficient from the x squared and the 8x only. Okay, and we don't want to factor the x's out, just the 2. So if I take that 2 out, I'm going to be left with x squared minus 4x. And I still have my positive 5 here. Okay? And now what I need to do is we want to create a perfect square right here. And so in order to create a perfect square, remember we have to take half of our coefficient and then square it. Okay, so we're taking half of this negative 4 and then we're going to square that, which would leave us with plus 4, and then we want to subtract 4 as well. And this is going to create our perfect square. And then what we want to do is we want to multiply this outside term here. Okay, and so when we do that, we're going to be left with a negative 8 because we're going to 2 times negative 4. And when we do that, we also want to create our perfect square on the inside here, which is going to be x minus 2 squared minus 8 plus 5, and that is equal to 0. Okay, now from here we can simplify and we'll be left with 2 times x minus 2 squared. Negative 8 plus 5 is going to be negative 3, and that is equal to 0. Okay, and now what we can do is we can bring all of our like terms to one side, or our non-like terms to the other side. So if I add 3 to both sides, add 3 here, and add 3 here, I'm going to be left with 2x minus 2 squared is equal to positive 3. And then I'm going to divide this 2 out in order to balance out the rest of this equation. So divide both sides by 2 to get rid of this guy, and this is going to be left with x minus 2 squared is equal to 3 halves, or 3 over 2. And now, remember, we have to get rid of this exponent, and so the only way to do that is to take the square root. And we need to do that to both sides. Okay? And so once we do that, we're going to be left with x minus 2 is equal to plus or minus, because remember, we don't know if it was a positive or a negative that gave us that square root of 3 over 2. Okay, it could be both. And so now we're left with x minus 2 is equal to positive minus rad 3 over 2. And to get this to the other side, we just need to add 2. And so we're going to be left with x is equal to 2 plus or minus rad 3 over 2. And this would be our final answer. And so you can see how we can't decompose that or do this by inspection just because we don't have the right conditions to do so. Okay, now let's look at what the quadratic formula is. Now, solving this equation, which I'm not going to do here, but I could do this in class for you. It would make more sense if I can just interact with you while I do this question. And so we're going to use our final product, which is going to be x is equal to negative b plus or minus b squared minus 4ac. And again, if it's a little daunting, I'll show you how we come to this using our quadratic equation. Okay, but this is called the quadratic formula. And this is a lot of fun to use and something that you'll be using and you could use to solve a question like this. Okay, so let's look at some of the examples where we need to use this equation. Okay, so with the quadratic formula, you'll notice that, first of all, if you just look at what we have our general form of our equation here. Ax squared plus bx plus c is equal to 0. And you can see where all these variables fit in. We have our a's here, and we have our b values here, we have a c here, and then and we have our x. Okay? Now, when we have plus or minus, that's when we're going to have two values of x potentially. And so let's look at this first question that we have. So find the roots of the following equations using the quadratic formula and give answers as exact values. So remember, as exact values in simplest form and to the nearest tenth. So remember, if we want them in exact values, then we don't want any decimals. They're also though asking, so this is where it's being a little sneaky. They want them in exact values, in simplest form, and to the nearest 10th. So they want both here. You're just like, what? But yeah, they want both. So you just make sure you give them both here. And so the first thing we want to do is we want to use our quadratic formula. So let's input the quadratic formula here. So this is going to be x is equal to negative b plus or minus the square root of b squared minus 4ac. And that is all divided by 2a. Okay? This is the quadratic formula. And if you look at what we have here, we have the general form of our equation. So this is going to be ax squared plus bx plus c, and that's equal to 0. And so the next thing we can do, we can just list the variables that are in our equation. Okay? So I'm just going to do it on the side here. I have my a value, which is going to be equal to 1. It's going to be equal to 1 because there's no coefficient in front of this x squared. My b values, these are going to be equal to 2, right? Because they're taking this middle term here. So this, in this case, it's equal to 2. And my c value, well, that's equal to negative 1. And so the next thing I need to do is I just need to fill in these coefficients for everything inside of the quadratic equation here. So negative b would be negative 2 plus or minus b squared, or 2 squared minus 4 times 1 times negative 1. And that's all going to be divided by 2 times 1, or just 2. Okay? Now we can simplify from here. Negative 2 plus or minus the square root of 2 squared is 4 minus, so this is going to be 4, subtract 4 times 1 times negative 1. So it's going to be, we're going to get a value of 8 here. Okay? And so if you don't believe me, I have 2 squared minus 4 times 1 times negative 1. And we're going to get a value of 8. Now remember, this is all going to be divided by 2. Okay, and so if I'm dividing this by 2, remember that we can also simplify this rad of 8 here. And so rad 8, remember, is, I'm just going to do this in blue to the side here. It's going to be rad 4 times rad 2, or also 2 rad 2. Okay, so that's how we can express square root of 8. And so that's going to be negative 2 plus or minus rad 2 over, or 2 times rad 2 divided by 2. And if we divide these all by 2, we're going to cancel out that, and that, and we're just going to, and that's just going to be 1. And so we're going to be left with negative 1 plus or minus rad 2. Okay, so this is one of our answers. And remember, we wanted it in exact values, but we also want it to the nearest 10th. So this is part of our answer, and the other part of our answer is just we need to solve this. Okay, so if I have square root of 2, I have 1.41. And so the first thing I'm going to do is I'm going to go negative 1, subtract that answer, and I'm going to have an answer of negative 2.4 if I round to this nearest 10th. Negative 2.4. But I'm also going to have another value, right? Because it's plus or minus. So I subtracted that. And so now I need to add that value. So square root of 2 was 1.41. Negative 1 plus that answer is going to be 0.41. Or to the nearest 10th, I'm just going to leave that as 0.4. Okay, and so that's how you use the quadratic equation. Now, I'd encourage you to do it for these ones as well. For something like this, again, this is going to be your A value. So A value would be 4. Your B value would be negative 12. And your C value would be 3. And you would just plug it into this equation. For this one, you have to rearrange this. And so the first thing you need to do is go 4x is equal to 12x if you FOIL this, plus 15. And then you're going to have to bring all these to the other side. and set this equal to 0. So this will be 4x squared minus 12x minus 15 is equal to 0. And now you can solve for your quadratic equation by simply setting this as your a value, your b value, and your c value. Okay? So that's all you need to do for those questions. So you can pause the video here and you could attempt to do these ones. And for your answers for both of them, you should find x is equal to 0.3 and 2.7. And then for this one, you should have x is equal to negative 0.9 and 3.9 once you solve it. And then your absolute values should look like this: 3 plus and minus the square root of 6 divided by 2, and 3 plus minus 2 times the square root of 6 divided by 2. So that's what your absolute or your exact values should look like. Okay, now let's look at this question here. Let's find the zeros of the quadratic function f of x is equal to negative 3x squared plus 4x plus 1. Okay, so if this is what I'm using, I know that a is going to be negative 3, b is going to be equal to 4, and c is equal to 1. And I want to find my zeros here and then give the exact values, but also I want to solve to the nearest hundredth. Okay, so we're using our quadratic formula of x is equal to negative b plus minus b squared minus 4ac, and that's divided by 2a. Okay, and so solving for x, we know that b was negative 4 plus minus 4 squared minus 4 times negative 3 times 1 divided by 2 times negative 3. Okay, so we're going to be left with negative 4 plus minus the square root of 4 squared is 4 minus 4, 9, negative 3, 1, 1. It's going to be 28, and we're going to divide this by 2 times negative 3 is negative 6. 28, so 28, remember, 4 times 7 is 28, square root of 4 is 2, so we're going to have negative 4 plus minus 2 rad 7 if we break this down. And we're dividing that by negative 6. And we can, from here, we can say, okay, well, negative 2 goes into this 2 times. And we're going to be left with 2. Goes into this 3 times, and 3. Plus minus 2 goes in that once, rad 7. Okay, and plus or minus, okay, so we're good there. But it's also equal to the nearest hundredth. Whoa, why is this so shiny? To the nearest hundredth, it's going to be 2 plus square root of 7 divided by 3 is 1.5 to the nearest hundredth, 1.55. So x is equal to 1.55, and if we subtract 2 minus the square root of 7 divided by 3, negative 0.22 to the nearest tenth, or hundredth, sorry. Negative 0.22. And there you have it. That's the quadratic formula.